Okay, let's get started. Um, okay, what's up, coders? Today we're gonna start doing, well, I'm gonna start with some dynamic programming questions. So, yeah, let's just get started. Here we have LeetCode 62, unique paths. It's a medium problem. Well, yeah, and then, so there are 2,838 likes and 195 dislikes. So it's pretty popular of a problem. So let's just get started. So a robot is located at the top left corner of a m times n grid, marked start in the diagram below. So there's a robot, and the robot can only move either down or right at any point in time. The robot is trying to reach the bottom right corner of the grid. So the robot is trying to reach the finish star here, and then how many possible unique paths are there? Okay, so this is like a very classic, I guess, dynamic programming problem. So the key here is that the robot can only move down or right, and yeah, let's just walk through an example. So let's say we have a 3x2, so 3x2 grid. So there are three columns and 2 rows. So from top left to bottom right, there are 3 ways. So right down, or right down right, or down right. Does that make sense? So there's a 3 column and a 2 row array. Grid, whatever. Yeah. So when you think about this problem, so you have a 2D grid, and so let's take this one for example. So you start from start, and then the number of ways to this part is 1, and to this part is 1 as well. And then the number of ways to this part is 1, because you can only move right or down, and likewise for the one at this end. So you realize all the grids at the edge, at the upper edge and the left edge, is there's only one way to get there. And when you want to move here, so when you want to move to any part of the grid which is not in these edges, you're just gonna have to add the 2 grids on top and the left. So for example, for you to reach this grid, you're gonna want to add this grid and this grid. So 1 + 1, 2, and there are 2 ways to get here. When you look at it, so so right down and down right. So that's 1 way. Those are 2 ways. And let's say you want to get to this grid. That's 3 ways because 3 ways. Okay. There's three ways because there are 2 ways to get to this grid plus 1 way to get to this grid, and that's an example shown here. 3x2 grid. So output is 3, and when you work so on and so forth, you get 28 for this one. So let's just get started coding. So we're gonna initialize a 2D array accordingly to the specs given. So I'm gonna do this using Python 3. So I kind of forgot the Python syntax. dp is equal to an array of, so we're going to initialize everything to 0 first. No, we're going to initialize to this array, and then 0 so how do I initialize a 2D array? So for x in range, since we want to initialize each grid, that's m in range m, for y in range n. So this should be our grid. So let's just try to see if this one prints out accordingly. So 7x3, 3x2. Test case, let's change this. 7x3, run code. Yep, got it right. Okay, now you have a table you have a 2D grid, and you want to initialize each row, and with the first row and the first column, everything to 0. So for x in M, so for each for the first row, dp of 0 of M is equal to 1, because there's only one way to reach those parts. And for x in N, dp of N of 0 is equal to 1. So we're initializing these part and this part to 1. Yeah. And then we want to populate the rest of the grid by adding so we want to populate the table by adding the previous left and top of the array. And we're going to start by 1 because we already populated the leftmost side and topmost side. So for, say, I in range 1 to N, I think you can interchange it. Therefore, I in range 1 to M, sorry, it should be J, dp of I, J is equal to dp of I minus 1, and J plus dp of I and J minus 1. Then you just return the bottommost, which is dp of M minus 1 and N minus 1. I think that should be right, or unless I got stuff interchanged. So let's see. For I in should be range M range index out of range. Ooh. Oh, this should be X, my bad. X, this should be X as well. I kind of heard into it, so. Oh, I think I got this interchange. It should be N and M. So. Cool, accepted. Now let's try to submit it. Let's hope it works. Cool, yeah, so runtime 28 milliseconds, which is pretty fast. Faster than 80%. We have a bad memory usage because we are using a dynamic programming strategy here. I'm not sure if you can use if there's another way to do it. I'm pretty sure there is, because this is like 5.77%, but yeah, this is one way to do it using dynamic programming. Yeah, I hope that made sense. So I'm just gonna re-explain things for people who don't really understand it. So just to clarify everything, so in the first row, everything is 1, initialized to 1 here, because 1 means that what was I gonna say? Yeah, so there's only one way to get to this row, any blocks in this row, because let's say you want to get this row, this block, and the only way you can get there is by moving down or moving to the right. And since you're already in this line, you can only move to the right, which means there's only one way. You have to go right. And then same goes for the one in the first column. So you can only get to any blocks in this column by just moving down. Right? So there's only one way. Hence it's initialized to 1. And when you think of it, for any other blocks that's not in the first column or the first row, the number of ways you can get there is the sum of the blocks in the previous, the sum of the blocks on the left of the current block and then on top of the current block. So let's say you want to get here, so it's 1 plus 2, and there are 3 ways to get to this block. So yeah, I hope that made sense, and thank you for watching.